Some more examples on equivalence relation. First example is let R square, that is R cross R. This set is what? R cross R. The set of all points in XY plane. That is, this set contains order pairs. This is the set of order pairs. For example, XY. This is order pair. This is the element of R square. And X dash Y dash. These are the two elements of R2. And the definition given in the example of relation is what? XY is related to X dash Y dash if X plus Y is equal to X dash plus Y dash. So this is the definition of relation. And the R square, R raised to 2 is what? Is the given set. And this wiggle is the notation for relation. Instead of capital R or another notations, the notation for relation is what? Wiggle, this sign. And what is the relation when XY is related to X dash Y dash? That is these XY, order pair XY and order pair X dash Y dash. These are the elements of R2, any two elements of R2. And when these two elements are related, if X plus Y is equal to X dash plus Y dash. So particular element of R square, suppose we take 1, 2 as the element of R2. And another element is suppose 1, 1. So if we take two elements of R2 such that 1, 2 and 1, 1, then these two elements are related under this relation. So answer is no, because 1, 2 means 1 plus 2 is 3 and 1, 1 means addition is 2. And so 3 is not equal to 2 and therefore 1, 2 is not related to 2, 1. If we take the two elements, suppose 2, 2, suppose if we take X and Y as 2, 2, and another element is what? 1, 3. That is 2, 2, and the order pair 2, 3 is 2, not 2, 3, 1, 1, 3. Suppose 2, 2 and 1, 3. These two elements are related under this relation? Yes, because 2, 2, addition of 2 plus 2 is 4, that is X plus Y is 4, and 1, 3, if we take X dash Y dash as 1, 3, then 1 plus 3 is 4. And so 2, 2 is related to 1, 3. So under these elements, under this relation, two elements are related if X plus Y is equal to X dash plus Y dash. And the question is, show that this wiggle is an equivalence relation. That is, we have to show this wiggle is an equivalence relation, means the relation is reflexive, symmetric, and transitive, and interpret the equivalence classes geometrically. So first, we have to show this relation is an equivalence relation. So we know that when the relation is equivalence relation, if the relation is reflexive, symmetric, and transitive, then the relation is equivalence relation. So first condition is a reflexive condition, reflexive property. So for this condition, take any one element from the set. So set is R2, and if you take the element order pair XY from R2, then what we have? X plus Y is equal to X plus Y. Note that this X plus Y and X plus Y both are same, and means XY is related to XY by using this relation. So XY is related to XY, and this XY is any element of R2, and this element related to itself, and therefore every element of R2 related to itself, and therefore the wiggle relation is reflexive. When the relation is reflexive, if each element related to itself, each element of that set. So this is the set R2, and if we take XY as the element of R2, then this XY is related to XY. Why XY is related to XY? Because X plus Y, addition of these two, and addition of these two, that is X plus Y and X plus Y both are same. And therefore this XY is related to XY, means every element of R2 or each element of R2 related to itself. And therefore the relation wiggle is reflexive. The second condition is symmetric. So we know that when the relation is symmetric, if one element is related to other, then if other element, second element also related to first, then the relation is symmetric. So take two elements xy and x dash y dash from R2 such that xy is related to x dash y dash. Then what we have by using this relation? We have x plus y is equal to x dash plus y dash. But we know that if we write, we can write this x plus y is equal to x dash plus y dash in this fashion. That is change the sides. That is x dash plus y dash is equal to x plus y. And what is the meaning of this equation? That x dash plus y dash plus is equal to x plus y. That x dash y dash is related to x y. This means x dash plus y dash is equal to x plus y means x dash y dash is related to x y, and hence the relation is symmetric, because if one element is related to second, then second is also related to first, and so the relation is symmetric. Then third condition, take three elements, suppose x y, x dash y dash, and x dash y dash, x double dash y double dash. These are the three elements of R2, such that x y is related to x dash y dash, and x dash y dash is related to x double dash y double dash. That is take three elements from R2, such that first is related to second, and second is related to third. And now we have to show this first is related to third. So what is the meaning of x y is related to x dash y dash? By using the meaning given in the example, x y is related to x dash y dash means x plus y is equal to x dash plus y dash. And what is the meaning of this x dash y dash is related to x double dash y double dash? That x dash plus y dash is equal to x double dash plus y double dash. And so from these two equations, we have x plus y is equal to x double dash plus y double dash, because x plus y value is x dash plus y dash, and x double dash plus y double dash value is the same x dash plus y dash, means x plus y is equal to x double dash plus y double dash, and this means xy is related to x double dash y double dash, and therefore this relation is what is transitive, because one is element is related to second, and second is related to third. Then we have first is related to third, and therefore the relation is transitive, and hence the relation, middle relation, is an equivalence relation, because the relation is reflexive, symmetric, and transitive, and therefore the relation is equivalence relation. Now we have to find the equivalence classes. So take any one element from R2, any element, suppose xy is the element of R2, and the equivalence class of this element xy is denoted by xy bar, or write in square bracket xy, order pair xy, write in square bracket. So this is the notation for equivalence class, and is what is the elements from R2, is the again set from R2, elements of R2, x dash y dash from R2, such that xy is related to x dash y dash, and that is what x plus y is equal to x dash plus y dash. Okay, so because xy is related to x dash y dash means what, x dash plus y dash is equal to x plus y. So what is the definition of equivalence class? Equivalence class of the elements is the set of the elements from the same set which are related to this element xy. So xy, equivalence class of xy are what? Is the element from R2, is the set of elements from R2 that are related to xy. Those elements who are related to xy are the equivalence class of this xy. And then what is the equivalence class? This is the equivalence class. Xy is related to x dash y dash. So that xy is related to x dash y dash, or x dash y dash is related to xy. Is the set of xy order pair, is the set of order pair from R2. Those are related to xy elements. Those are related to xy element xy. But xy is related to x dash y dash means x plus y is equal to x dash plus y dash. And if you take x plus y is equal to, suppose k, suppose xy is x, suppose x is 1 and y is 2, then what is 1 plus 2 is 3, right? Like that, x plus y is equal to, suppose k, then we have x dash plus y dash is equal to k. And what is this x plus y is equal to, x dash plus y dash is equal to k, is the equation of line passing through the point k0 and 0k. What is the geometrical meaning of this x dash plus y dash is equal to k? This is the equation of straight line passing through the point k0 and 0k. So how we can obtain the point k0 and 0k? If we substitute in this equation a y dash is equal to 0, and we have x dash is equal to k. So k0 is the point. And if we substitute x dash is equal to 0, then what is the value of y dash? Is k. So k0 and 0k. So here is the k0 and here is the 0k point, and we join these 2 points by using straight line. We have this. So this is the equivalence class of this element xy. That is the equivalence class of xy is what? Is straight line passing through the point k0 and 0k. So this is the equivalence class. If we take another point, suppose x1, y1, then its equivalence class is what? Is again straight line passing through the, if you take this x1, y1, x1 plus y1 is equal to k1, then these 2 points k1, 0 and 0, k1. So if you take another point, suppose x2, y2, and suppose x2, y2 addition is k2, then what is the equation of, what is the equivalence class of this x2, y2? Is again straight line passing through the point 0, k2 and k2, 0, right here, k2, 0. So these are some equivalence classes. So under this example, equivalence classes are the straight lines. Next example, again of the same type, n cross n or n square. Instead of r square, here is n square or n cross n. And the two elements of n cross n, again order pair. Elements of n cross n or n square are order pairs. Suppose AB and CD are the two elements of n cross n. Define AB is related to CD is if A into D is equal to B into C. If these two are equal, then we say the two elements are related, and so that this relation is an equivalence relation. So when the relation is an equivalence relation, if the relation is reflexive, symmetric, and transitive. So these are the examples of order pairs. So n cross n. So these A, B, C, D are now in natural numbers. If you take this instead of n cross n, r cross r or r square, then A, B, C, D becomes a real number. In the previous example, it is r square. R square means r cross r, means the elements are real numbers. Entries are real numbers in the order pair. But here, AB and CD belongs to this n cross n, are elements of n cross n, means A, B, C, D all are natural numbers. That is, the values of A, B, C, D are what? 1, 2, 3, 4, 5, 6, and so on. So when the two elements are related, if it is multiplication, A into D is equal to B into C. So, for example, suppose if we take the element AB as 2, 3, this element as 2, 3, and this is suppose 3, 2. Then what happened? 2, 3, and 3, 2. So 2 into 3 is 6, and B into C again 6, and therefore 2, 3, and 3, 2 are related. So when the two elements are related, if A into D is equal to B into C. So this is the relation given in the example. So we are given a set. What is the set? N cross N, and the relation notation is Wiggle, and we have to show this relation is an equivalence relation. So first condition is reflexive. Take any element from N cross N. Suppose AB belongs to N cross N. Then what happens when AB is related to AB itself? If A into B, A into this, A into B is equal to B into A, and we know that A into B and B into A both are same, because these are natural numbers, and multiplication of natural number is commutative. What is the commutative law? AB is equal to BA. This is commutative. If you take addition, for example, if you take addition is also commutative, because 2 plus 3 and 3 plus 2 both are same. Answer is 5. While multiplication 2 into 3 is 6 and 3 into 2 is 6. So multiplication is commutative. But subtraction is not commutative. 2 minus 3 and 3 minus 2, these two are not same, because 2 minus 3 is minus 1 and 3 minus 2 is 1. So that is the subtraction is not commutative. While addition and multiplication is commutative. So here A into B is equal to B into A, and therefore AB is related to AB. And therefore the relation is reflexive, because every element of N cross N related to itself. When the relation is reflexive, if the every element of the set related to itself, then the relation is reflexive. And this AB, element AB is related to AB, and therefore the relation is reflexive. The next condition is symmetric. So when the relation is symmetric, if the one element is related to second, and if then second is also related to first, then the relation is symmetric. So AB is related to here is AB and CD. These are the two elements such that AB is related to CD. One element is related to another element. Then what happened? AD is equal to BC by using the given condition given in the example. So AB is related to CD. We have what we have? AD is equal to BC. And now we have to show CD is related to AB. So when CD is related to AB, if C into B is equal to D into A. So we can write AD is equal to BC in this fashion, that C into B, that is interchange the sides. That is right side element in a quantity in the left side and left side element in the right side. And replace the places. That is BC, right? BC instead of BC, CB. And this multiplication is commutative because these ABCD are natural numbers. And so CB is equal to DA. We can write, we have from this equation, CB is equal to DA very easily. And CB is equal to DA means CD is related to AB. When CD is related to AB, if CB is equal to DA. And we have CB is equal to DA, and therefore CD is related to AB. And so AB is related to CD, then we have CD is also related to AB, and therefore the relation is symmetric. The next condition, take three elements from N cross N, AB, CD, and EF, such that one is related to second, and second is related to third. AB is related to CD, and CD is related to EF. Now what we have? Now what we have to show? AB is related to EF, but AB is related to CD implies what? AD is equal to BC. We have this from this. And CD is related to EF. What we have? CF is equal to DE. And from these two equations, we have to show AF is equal to, we have to show this AB is related to EF, means AF is equal to B. So from this AD is equal to BC, what we have? A by B, shifting this B to right, left side and shift this D to right side. So AB is equal to D, C by B. A by B is equal to C by B. And from this equation, what we have? Shift this D to left side and F to right side. So what do we have? C by D is equal to E by F. And therefore, AB is equal to A by B is equal to E by F. We have this from these two equations because A by B is C by D and E by F is also C by D, and therefore A by B is equal to E by F. And then we have AF is equal to BE from this. And AF is equal to BE means AB is related to EF, because when AB is related to EF, if AF is equal to BE. So we have this AF is equal to BE, and therefore AB is related to EF. And so the relation is transitive. Why the relation is transitive? Because if the one element is related to second and second is related to third, then we have first is related to third. This AB is related to EF, and therefore the relation is transitive. And therefore the relation, this riddle is an equivalence relation because the relation is reflexive, symmetric, and transitive, and therefore the relation is an equivalence relation. And now we have to find the equivalence classes. Suppose there is no question to find equivalence classes, but for interest we are going to find equivalence classes. So take any element from N cross N, AB, suppose AB, and the equivalence class of this element AB is written by AB bar is equal to the elements from N cross N is the set of elements from N cross N. Suppose CD, such that CD is related to AB. So what is CD is related to AB? If AD is equal to BC, and AD is equal to BC means A by B is equal to C by. If this happens, then the two elements are related, or this is the set of elements from N cross N satisfying this property, A by B is equal to C by. So this is the equivalence class of AB. Next example is again of the same type. Suppose the R square is the given set and Hegel is the relation. Define this by using this relation. X1, Y1 is related to X2, Y2. If X1 square plus Y1 square is equal to X2 square plus Y2 square. So show that this relation is equivalence relation and describe the equivalence classes of 3, 4, particular element 3, 4. We have to find the equivalence class of 3, 4. So first we have to show the relation is equivalence relation. That is, the relation is reflexive, symmetric, and transitive. The first condition reflexive. Take any one element from R2 and show this element is related to itself. So x1, y1 belongs to R2. So when x1, y1 is related to x1, y1 itself, if x1 square plus y1 square is equal to x1 square plus y1 square, and this is very obvious that x1 square plus y1 square is equal to x1 square plus y1 square, and this implies x1, y1 is related to x1, y1. And thus, we have what we have for any element x1, y1 belongs to R2. If x1, y1 is related to x1, y1, that is each element of R2 related to itself, and hence this result is a reflexive relation. The next condition, symmetric. Take two elements from R2, x1, y1 and x2, y2. These are the two elements from R2, and such that x1, y1 is related to x2, y2. That is, first element is related to second element. And now we have to show the second element is related to first element. So x1, y1 is related to x2, y2 implies x1 square plus y1 square is equal to x2 square plus y2 square. And interchange the sides. We have this x2 square plus y2 square is equal to x1 square plus y1 square. And this implies x2, y2 is related to x1, y1. And therefore the relation is symmetric, because x1, y1 is related to x2, y2. Then we have x2, y2 is related to x1, y1. And therefore the relation is symmetric. The third condition is transitive condition. Take three elements from R2, that x1, y1, x2, y2, x3, y2, three order pairs, and such that the first is related to second, and second is related to third. And now we have to show first is related to third. So x1, y1 is related to x2, y2 implies this by using the definition given in example, that x1 square plus y1 square is equal to x2 square plus y2 square. And x2, y2 is related to x3, y3 means x2 square plus y2 square is equal to x3 square plus y3 square. And from these two equations, very obviously we have x1 square plus y1 square is equal to x3 square plus y3 square. And this means x1, y1 is related to x3, y3. And therefore the relation is transitive. And now we have to find the equivalence class of element 3, 4. So how we can denote the equivalence class of 3, 4? Write this order pair 3, 4 in square bracket, or write order pair 3, 4 bar. These are the notations for two notations for equivalence class. Okay, and is the set of elements from R2, again xy belongs to R2, elements from R2 such that, right, to this colon or right oblique side, such that, read it as such that xy is related to 3, 4. Those elements whose are related to 3, 4 from R2 are the member of this set equivalence class 3, 4. xy belongs to R2, elements from R2 such that 3, 4 is related to xy, or xy is related to 3, 4. So what is the 3, 4 related to xy means 3 square plus 4 square is equal to x square plus y square. And what is this 3 square plus 4 square? 3 square is 9, 4 square is 16, and 3 square plus 4 square, that is 16 plus 9 is 25, and it is square of 5 square. And so what is this x square plus y square is equal to 5 square? Geometrically, what is this? Is the equation of what? Circle with center origin, whose center is 0, 0, and radius is 5. So if we have to draw the figure of this equivalence class of 3, 4, then draw the circle with center 0, 0 and radius 5. So we can also interpret this equivalence class of 3, 4 geometrically. So these are some examples. Again, the same example. One more example from Z. Z is the set. Let Z be the set of all integers, and AB is related to AB are the element of Z, and when A is related to B, if A minus B is an integral multiple of n, that is multiple of n, A minus B is multiple of n means what? A minus B expressed in the form n into some integer, or some k belongs to Z. So this is the definition, and we have to show this is an equivalence relation on Z. So first condition is reflexive. Take one element from Z. Suppose A is the element from Z, and then what is when we say A related to A? Now we have to show A related to A. When A related to A, When A related to A, if A minus A is multiple of n, so what is A minus A is 0, and we can write 0 as 0 into n. That is 0 is multiple of n, and therefore A related to A. And therefore, A is any element of Z, and therefore every element related to itself, and therefore Wiggle is a reflexive relation. Now we show this relation is symmetric. So for that, take two elements from Z, such that A is related to B. Then what do we have? A minus B is multiple of n by using definition. And A minus B is multiple of n means A minus B expressed in the form n into some integer. Multiple of n means it's expressed in as a n into some integer. And then B minus A is what? B minus A is minus nk, and we write n minus nk as n into minus k. And this minus k is also integer, means B minus A is also multiple of n, and therefore B is related to A, and therefore the relation is symmetric. The next, take three elements from Z, A, B, C, such that A is related to B and B is related to C. Then what happens? A minus B is multiple of n and B minus C is multiple of n. A minus B expressed in the form n into some integer, suppose k1, and B minus C expressed in the form n into some integer, suppose n into k2, where k1 and k2 are the integers. Then what is the addition of these two? A minus B plus B minus C is n k1 plus n k2. Take n as common, then k1 plus k2, suppose k1 plus k2 is k. Then we have this A minus B plus B minus C is equal to nk. And then A minus C, this addition subtraction is what? B minus B plus minus B becomes 0. And so A minus C is equal to nk. That is A minus C expressed as a n into some integer as a multiple of n. So A is related to C, and therefore the relation is what? Is transitive. Because A is related to B and B is related to C, then A is related to C. And then we have to find the equivalence class. Take any element from Z, and the equivalence class is what? B from Z, another element from Z, such that B is related to A. But B is related to A means B minus A is multiple of n, and that is B minus A is equal to nk for some k belongs to Z, that is B is equal to A plus nk. So if instead of this n, we can also take 2, is A minus B is integral multiple of 2, that is A minus B is even integer. All these examples are sent. Instead of n, we can take a particular 2, 3, 4, 5. And these are some examples to given in the exercise. Solve all these exercise. And if you have any problem to solving this exercise, the answers are also given. Answers of some problems are also given. But if you have if you have any problem while solving in exercise, communicate me with the WhatsApp group, our WhatsApp group, and also solve problems. Your solve problems, send me through WhatsApp group, our WhatsApp group. So in the next lecture, we'll see topic function. In the next lecture, we'll see the topic function. So up to this video, all about equivalence relation. So what is the important in the equivalence relation? Only one example is in the question paper, that is show that the relation is equivalence relation. And also the definition is also important, definition of equivalence relation and equivalence class. So only one example on the equivalence class and equivalence relation in the example, in the exam.